USA. It's indeed a big pleasure for me to, host the 11th edition of the Knowledge Byte session that we have been, conducting since more than a year now. The aim of this session is to acquaint the senior leadership of SAIL as well as their young mentors about emerging technologies, understand the nuances of the same, and we can understand how we can leverage them into our steel operations. In that series today we are going to have a talk about 3D digital twin, and for that we have a very able team from Visionaries, Sri Patudas Gupta sir and Nikhil Chauhan ji, who have joined from USA, who would be sharing the expertise. I would like to welcome, before we proceed further, I would like to invite Sri Atanu Mukherjee sir, Head of Academics at Steel Authority of India Limited (MTI), to kindly welcome the expert panel as well as welcome the senior people from SAIL leadership who have joined today's session. Atanu Mukherjee sir, please.
Thank you, Chandranath. And very good evening to all of you. And as Chandranath rightly mentioned, this is every month we are conducting these knowledge bite session. And the purpose of the knowledge bite session is basically it provides a trigger to think and also to take the reverse mentoring process forward. So basically in this knowledge bite session, we are focusing on the I request the participant please mute. Otherwise, it is creating little bit of disturbance. Please mute. Jannath, PA, please mute. I think from Parthasa when you can mute.
Nikhil, can you mute?
Yeah, I think I will do that.
Yeah.
I would request participants to kindly keep your mic on the mute mode. Also, sir, I am getting certain requests from participants that they are not able to join the call. Please see that if they, the call has any setting, if they are not able to join. Yes, let's okay. Continue, Atanu sir.
Yeah. So basic purpose of this knowledge bite session is that it provides a lot of trigger to think on the emerging technology. Basically this particular session, the knowledge bite session, is mainly on the emerging technology. So from this front, once we have the adequate knowledge on the emerging technology, we can take this reverse mentoring process forward in Steel Authority of India Limited. And for this, once again, I like to welcome Partha Dasgupta Sahab and Mr. Nikhil Chauhan Sahab, who is connected from US. And also, Nikhil Sahab has really taken a lot of pain. Right now, it is early morning in US, and he has taken a pain to share his expertise in this area of 3D digital twin. So really, we'll get a lot of benefit from you, sir. And this every month as we are conducting this session, so we will be conducting in future also, so that finally the mentee who are at very senior level, that they are in the rank of chief general manager and executive director level, and the mentor who are the young people, they get a lot of insight from this knowledge bite session. Also, I like to welcome our Executive Director, Digital Transformation, Betroka Sahab, for sparing his valuable time, and he is also connected with us. With his presence, we'll get a lot of insight on this topic. Also, I like to welcome all the Executive Directors who are connected today in the online session, and all the Chief General Managers of Steel Authority of India Limited who are connected in this online session. So once again, welcome all for the knowledge bite session which will be taking place. Thank you. Over to Chalana.
Thank you, sir. Thank you very much. So let's quickly start because we are already 10 minutes behind time, and we used to respect the schedule. So we have set a cutoff time of 5 p.m. So let's see if we can do justice with the time. So I would like to invite now Parthudas Gupta sir and Nikhil Chauhan sir to kindly take forward the session. Sir, please.
Thank you, Chandra, Mr. Mukherjee, for your kind words. And it is indeed a privilege for us to be amongst you all, the SAIL team. I myself being a SAIL product, my father used to work in Rourkela Steel Plant. There is an emotional connect. Nevertheless, we have to work together progressively, and as we all know, artificial intelligence, 3D, metaverse, these are all the buzzwords today, not in terms of just talking about, but people who are using this are reaping significant benefits in terms of enhancing the performance of their assets. So I now would like to request Nikhil Chauhan, who is an authority, and we have shared his profile. I'm sure you all have known from the profile that he is absolutely an authority. But the as they say, the taste of pudding lies in eating. So Nikhilji, over to you.
Thank you, Parthuda. And first of all, thank you very much, Mr. Atanu and Mr. Chanda, and thanks for the leadership of SAIL and all the mentors. Really, it's privileged to be here, and more than that, for me, I mean, though I present to many, customers and partners around the world. I myself lived in 11 countries before coming to US and settled here. But when it comes to our Indian clients or Indian, audience, it's always a emotion. And I mean, when you sit in India, it's okay. But when you sit outside and you face your own people, and your own PSU is a different emotions. I think I can feel that now. So with that, it's a pleasure and it's a privilege to be here. I know we have limited time, so what I'll do, uh, probably it may go a little bit 5-10 minutes, but I'll try to wrap up within the time. I know it's a festive time, and it's your family time now. So with that, let me share my screen, and we'll just go through the slides. And what I'll do, I'll go through slides as well as I have some demos through our AI platform. I will go through the DAC, the platform also. So let me know when you see my screen.
Yeah, we can see your screen.
It's visible, sir. Okay, wonderful. So just a little bit about Vision Eyes. So we are a digital twin AI and Gen AI, generative AI company. What we do basically, we enhance our clients' plants' reliability, sustainability, and operational excellence, productivity. So who we are? Basically, we are a virtual and intelligent plant provider. Very simple, using the technologies. We have a very experienced team, coming from the domain side also and AI side. So people from steel processing, people from energy. So we have those type of people, power and AI, Gen AI, all experts sitting in here in US as well as in India and Middle East and elsewhere. What is our strength, or where we boast ourselves, that we will bring data from different sources. And data, as you know, people are saying data is a new oil. Yes, it's a new oil because data had been there. We have been collecting through SCADA, from DCS, or documents also now, right? But we never got the insight from those, or we were getting through more traditional tool like Excel or some other tools. And but what we were doing only one data at a time. Here now we are basically bringing all the data at one time, and as Vision I we say, single source of truth. The second is, we have an integrated AI and generative AI end-to-end solution. So many people are saying, oh, we can do ML or generative AI. What we are doing, we are bringing these two together, and we are not only monitoring or diagnosing, but we are predicting and prescripting. We are telling what is the cause of the problem, if there is a problem, and what action you need to take. So that's where we are coming. Finally, we have this 3D and Gen AI. When we bring everything together, you get an immersive experience. And the Gen AI bring human-like conversational. So very much like that expert is basically doing the job. Let's say for reliability, we call reliability agent, troubleshooting agent. So those are the things we are bringing. These are some of our clients in the left hand side, and what we are basically proud of, that most of these projects, AI projects, basically giving a very attractive ROI, more than 10 times. And payback of most of these applications is less than 6 months. As such, it's not only us. I think others also must be providing similar value if they are successful in AI world, because the cost of operations and cost of implementation is very low compared to the value you get. So as I said, we bring three data sources together. IT, which is more like a CRM, accounting, finance, pricing, and everything you will bring from there. Then OT data, which is very important, right? All of us are aware of, if you are in a plant life, that there is a data in historian, SCADA, EVA. So, and asset data, process data, equipment data, you bring those data also. And finally, engineering data. And many companies are not bringing engineering data. That's what we do. Bringing engineering like drawing, PNID, connectivity, data sheet, manuals, process description, unstructured text, images, like and drawings, and how you can read those. Now there are tools, right? ML, NLP was there, natural language processing. Now you have generative AI. So using these and making the knowledge graph, they should talk to each other and you get the insight out of it. So that's the value of our V Suite, which is a platform it brings. So as you can see, this data is coming, and now you see this data also. So in this data is more like for our 3D digital twin. So 3D digital twin, I'll talk more in detail. You build using either a 3D CAD from the engineering side when you install the plant, or with the laser scanning. If you don't have, or you don't have Ashbuild, then you can laser scan and then bringing those into the using point cloud, our software built 3D digital twin. So here data lake and everything is coming. So this is B Suite platform. Then over that we build application. Now, as you know, right, bringing data at one place is also not a fun. It's a, okay, data was residing here. You bring data at a centralized platform, then so what? Unless you see the value of this, means using applications, there is no good. So here we build applications. On the right hand side, these are when you have a 3D, what is the application of 3D, right? So the 3D applications are like for inspection. You can do inspection very effectively when you have a 3D, because you can have data, drag and other things here, and you can store everything there. Maintenance planning you can do when you have a 3D. You don't need to go to the site when you are doing planning. Similarly, turnaround, very useful for the turnaround. When you are having a turnaround, you can use this for planning purpose. It can interface with your Primavera, SAP, other system. And then you can basically track also when you are executing the turnaround. So in turnaround, as you know, if you can reduce the schedule, it's a big thing. It's a big saving, means you can start your project early. And that's where our 3D comes, because it is helping our customer to reduce the turnaround schedule. Similarly, for the training purpose. So training right now, what we do, okay, intern has come, new employees has come, or even experience, we say, oh, go to my plant now and see how my boiler is working, how my or rolling mill is working. You don't need to go there. You have a 3D, you can get the training here in a safe way, right? And do some scenarios analysis also, scenarios. Similarly, in operating environment, you have a immersing operating environment. You can say temperature, pressure, everything. So you can immerse into it and you have performance of your plant. Now on the left hand side, these are more AI generative AI solution, more mathematical or engineering based. For example, real time performance monitoring. With the 3D or without 3D, and not only monitoring but diagnosis also, and I will show you. And the predicting any upset in the operation side or maintenance side, like equipment side or process side. And not only predicting, detecting and identifying the cause and doing a what if. Then you have optimization, process performance optimization means, let's say you have a blast furnace, or you have any area where you want to reduce the energy consumption or increase the yield or production. That's where optimization will coming, that hey, I'm making this much profit, let's say $200 million. How I can make 220 million, right? 10% extra. And that's where process performance optimization will come. Then you have generative AI use cases. I will show you where you can use for troubleshooting, you can use for HSC, you can use for different other areas. And sustainability, carbon molecules or any emissions monitoring and reduction. So we have all these, and I will talk briefly about all these things. So before I go into the platform, I know we have a question and answer session at the end, but I would love to take any question you have until now.
Yes, I think Nikhil, we can go ahead. We can take Q&A towards the end.
Okay, no, thank you, Mr. Chandra. So B Suite here is basically different technology, how it works. We have a digital twin modular approach. So you don't need to take everything, right? I mean, or you don't need to apply everything as a operations or a customer. Here you have data, definitely you need to bring. Now the data also, you don't need to bring all the data at one time. That's a bad strategy. I would say, keep your vision that I want to go there in 5 years. I want to make my whole sale, Bokaro to Bhilai to every plant digitalized in 5 years, everything on 3D and all analysis I can do. But start, with small means, oh, let me start one unit, one area, bring that data, bring relevant data, bring relevant engineering data, but your data lake would be such that it is scalable, that it will bring all 5-7 plants at one place, and even other corporate side also. Then once you have this whatever you need, then you build 3D, and then you build the applications as we talked, right? So there are different technology, IoT, digital twin, AI, generative AI, these technologies are coming, right? So it's a modular approach. That's what I wanted to say. So what I'll do, I'll just go through like from bottom to top. Okay.
Poddar sir, please mute your audio. Hitesh Poddar sir, mute your audio.
Thank you very much.
Nikhil sir, please continue.
Yeah. So first thing, let's talk about how we build 3D digital twin. So for 3D digital twin, this is more like a visualization first. We'll make it intelligent, right? So first we need to have a skeleton. So for that, we need drawings like 3D CAD of the existing plant. And if you don't have, then we will do the laser scanning. Or if it is not like edge built, then we use laser scanning also for the portion where 3D is not available. Then based on the software point cloud we have, you get the 3D skeleton again. Now this 3D digital twin is basically a very light mode. You can use your iPad everywhere. It's like this one is very difficult 3D CAD, what you get in the installation phase. This is light mode, and that's the uniqueness that you can use for operation maintenance phase also. Now what we'll do, we'll make it intelligent. Now we will connect with different documents. And one of the very important document is like PNID, process instrumentation diagram. So here, and any document, and this is a typical, so here you have all the tags and everything, right? Pump tag and instrument tag, control wall. Basically, in the ML, machine learning and natural language processing, basically help us connecting these tags with the 3D. Because these dolls and equipment are in 3D also. Now, so you are mapping using ML and NLP. So that is the beauty of all the documents we need to put that way. Let's say you bring a manual is of pump 101. It will go to pump 101. It will be sitting in a structure under pump 101. So all those things, like we call it knowledge graph. Real-time data also would be coming, and I'll show you. So first let's talk about this, here 3D and 2D. Like it is connected. everything is mapped, right? So that's the way software will do. It will create the asset master registry also. You know how many equipment are there and what type of equipment are there. And this is very useful for connecting with your spare parts, right? So for this pump, you need spare parts also. For this compressor, you need spare parts. So that way, your inventory management system is also connected and you can optimize. Means then you can do based on the demand how much stock you need to keep optimum, right? So very useful. Then you bring the real-time data, right? So real-time data coming from the plant, like your pressure, temperature, and flows, production, raw material, everything coming. You manage the data. Ingestion is there, data manage. Then you contextualize, means pump data will be sitting under pump in a structured way, and you develop the knowledge graph. Contextualization means PNID, drawing, images, connected, all talking about this pump. They need to be connected, and that's the beauty, and that's where you get more insight when you connect everything together. Then you develop AI ML modeling, and finally you do the visualization. So AI ML modeling, we have algorithm, and I'll talk about those, how we do that. And visualization is basically on the dashboard or in 3D. Um, then then you get a digital twin is become a replica of the actual plant, like this, right? Once you bring everything connect together, you see 3D, you see the tags also. Instrument tags. Sorry, I have the allergy. In Houston we have a lot of allergy. So here you see the instrument tags, and you get connect with the all the different systems here. um, like you have APM system, you have other vendor system. So now that's another thing. You can connect with any vendor system, the 3D, and finally you can see individual equipment detail also here.
Sorry. Sir, you
Yeah.
have to create
Okay. So let me continue. Just I wanted to show you how the platform look like. We were talking about the platform. So we have this B Suite platform, and these are different applications. Let me go to B Smart, which is our data AI platform integrated. And here I will be, let's say we have all these, we can bring data from any source. You see here, and suppose historian is OSI Pi, I will connect and I will get the data. All the sensor tags are there. Then I can take whatever I need for my molding purpose. So I just wanted to show you how the easy is nowadays to this AI model and everything. Then you need data management, everything. I don't know, I don't want to go in detail, but you want to understand the pattern among different parameters, right? So that's here you will see the correlation mapping, that this parameter correlate, negatively with this, let's say. So those type of things you need to understand in AI world. Once you understand, then you store the data contextualized way, as I said, and then you do feature AI ML modeling or feature first. You can put the KPIs. You know there are positive, negative. All the operations are there. Then you can do the modeling here. Modeling like regression. All the tools are here. Algorithms, and let's say I choose this, and that's the way you can basically finally see actual and predicted. So your model is trained and tested and then deploy. So just wanted to show that nowadays tools are there that you can train and test the model using algorithm and deploy very quickly. So I just want to go back to our slide deck. So first, now we go to the applications, right? So we have built the 3D.
Yeah,
We have
just
built.
Nitin, I think we have some participants whose mic is on unmute mode. Dear participants, I think somebody's
Rajesh
mic
Kumar,
is.
Jatuk sir, Rajesh Kumar and Jatuk sir, please unmute.
No, I unmute them. Oh,
All
mute
right,
them.
thank you.
Not unmute, mute them.
Mute them, mute them.
Yeah.
Okay.
Is it better now?
Yes, yeah.
Please. Okay. Yeah. Sorry for that. So we have built we have brought the data into the 3D, make it in data oriented, contextualize the data. Now let's build the applications over it, right? That's where you see the value. So first thing, we will build real time performance monitoring, right? Which is you can see your plant how it is working today in real time, right? So you build the data from here, go to the platform, we build some models, equations, because we need KPIs, right? You don't get everything from EBA system or from your SCADA. So that's where some engineering equation will come and you get the KPIs on the dashboard. Production, energy consumption, for the overall plant, then up to the equipment level, right? And then you can see in 2D digital twin, or you can see everything in 3D digital twin. And then if there is a problem, then you get the alert like KPI on the here. If this KPI is not up to the target, you click here, it will take you to 3D or 2D and say, hey, this exchanger is a problem, right? And then you can drill down further, do the diagnosis, identifying the cause, and that is basically you get the answer. Once you know the cause, you can get the recommendation also. I'll show you. And basically you can overcome these issues. So now I go back. I'll take remote performance monitoring. Now this one I'm going to show you for a petrochemical complex. The fundamentals are same. Okay. So there are different modules we bring here. So we are talking application now, right? So you see overall dashboard of the whole plant, high level for C-level people, right? Oh, how much is production? As I said, this is for petrochemical, but fundamental are same. I can see all the utilities at one place, critical equipment, how they are working. If any equipment is not working, you get the alert, you can drill down why it is not working. Then I will go to my system level. In each plant, there are different unit system. Let's say I go to charge gas compressor. I see all 2D here, real-time data, everything, KPI of that system. If there is a problem, I can go here. Let's say this is alert. I can see why there is alert. And I see, oh, efficiency is going down of this compressor. Means power consumption is going up. So I can further, drill down. One of the things before I go there, I want to even in 3D, right? So let's say I want to see in 3D this call, everything. So it will take me to the 3D side, how my 3D is basically working and showing. So you see 3D, or this compressor was having a problem, we saw the alert. But I can see real-time data also here. And these are customizable. We can make better UI, 102 degrees Celsius. I can see the performance of this compressor, efficiency 72, and that's why it's red, because low efficiency. But let me go back here. We were here. Sorry. Charge gas compressor. Yeah. So I will kind of go back. Why efficiency is low? So then my AI is basically telling me, oh, it has a correlation map. This compressor efficiency correlate with these. So using correlation, I come to know this parameter and this parameter, they are basically influencing my efficiency. So let me bring this parameter first. So my efficiency is going down because this one below, because quench all outlet, there is an exchanger, its outlet temperature is low, right? Okay, and that's the way it is showing. I can see COT, coil outlet temperature, which is a upstream heater coil, and that is influencing. Yeah, so this is going down efficiency because my coil outlet temperature is going up, right? So now I identified two parameters are basically influencing my efficiency. And this one has come from AI, that these four top parameters are basically affecting your efficiency. Now I will go and I will ask generative AI. Now generative AI has been trained based on your documents, manuals, operations log, maintenance log, process description, 100 documents in this plan, and you have a real-time data. It understands what is happening in this compressor. So I will still ask, what may be the potential causes of high CO2, low quench of outlet temperature. Remember those two parameters we identify from the AI. Now generative AI is where it will tell what is the cause of the problem. And it is very quickly saying quench exchanger is not efficiently removing heat, or quench exchanger is falling. Then, okay, so quench exchanger is the main cause. Then I say, what action should I take to overcome the issue, right? And then it will extract the information, give you the answer, because it has all the basically knowledge base. And it's an increased flow rate of the quench oil and ensure even distribution of quench flow, or offline, online cleaning, including steam air decocking. So I can do the cleaning, right? So for that, let's say this one is done. So I can go to my 3D again and look that, let's say, exchanger. Remember, exchanger was falling. And as I said, my AI, generative AI only know that exchanger cleaning is required. It basically do the isolation also, right? So this is basically based on the generative AI. Now in parallel, this is 3D. It starts, you can do the, your isolation philosophy has been implemented. You can take out the bundle, clean it, put it back. But in parallel, the beauty of 3D, you see this exchanger also getting into red, not red fully. So there is a color coding automatically come. But here when you are doing this, or you come to know in the plant, oh, in 3D, this also needs something, right? I mean, it is on the verge of. So you can do the maintenance activity of these together, and you can be more efficient in your maintenance activity. That's the basically beauty of integrating 3D and the other applications. Now I'll go back here. So this was remote performance monitoring. Let me go to the other application. So you must have seen predictive maintenance. Like equipments are everywhere in every plant. It can be rotating equipment, it can be static equipment. Fundamental is same. So what happens here? We need to develop these two models: anomaly detection, predictive model. And then the cause engine, identify the cause of the problem. And the what if analysis means, oh, system will down, I can do what if, change some parameters, and I can take the action and avoid this unplanned shutdown. So for these, you use historical data. We have pre-trained model, but still based on your equipment will take that data, train, test very quickly, and deploy. Once deploy, then real-time data is coming from any machine, right? It can be exchanger, it can be rolling machine, it can be gearbox, it can be compressor, pump, anything. And if there is no problem in this, your anomaly score will be normal, 0, or 1. But if there is any anomalous behavior, your anomaly score will show high and continue to be high if there is problem increasing, and you will see the contributing factors of that anomaly. And then you can get how much time is there remaining to fail. And this one tells you what is the cause of the problem, or what will be the cause of the problem. And that's where FMEA come, our generative AI come. We have FMEA library, but generative AI looking your FMEA, looking your manuals, maintenance history, and all the OEM documents, and telling you this is the cause of the problem up to the component level. That your bearing is a problem, your shaft is misaligned. Up to that level, it tells. So let me just go back again to our use case, predictive maintenance platform. So I'll show you compressor one, but again, we are the demo. Fundamentals for any equipment would be same. Like we have seen the real-time performance monitoring, you can do for the whole steel plant that way. Or for, let's say, blast furnace only, or for, we have done, and I'll show you those. Here, centrifugal compressor. Okay, so overall, compressor health. Here you see if there is an alert, you see here, alert. And this is this is seal is having a bad health. let's say your body is there and my heart is having some problem. Same in the equipment also. There is a particular equipment is having a problem, particular component is having a problem. And that may not be critical, right? Depending on criticality, equipment may fail or it's okay, it continue to work. And that's the way the health comes. So you see here, my anomaly score, was here, which is normal, and then it started increasing. So my remaining time to fail obviously will decrease after some time, right? 1 week, 2 days, like that. And so I have enough time to do the diagnosis and take the action. So I was here, my anomaly score increased. I will see my contributing factors here. That primary seal filter differential pressure is the major cause of the problem, right? So I know now, and I can go my cause analysis. I will take anomaly score, primary seal filter. I see, yes, they correlate very well. So this means primary seal differential pressure is the main cause of the problem. Now I will ask my generative AI copilot, hey, tell me, find the apparent cause of the contributing factors of this equipment, right? And it is a very structured approach. We need to identify, say, what is the cause and what is the recommendation. Now it will bring, extract the information from FMEA, from documents, and your FMEA, they have severity score, everything is bringing, sorry, and telling the score, the seal filter clogging is the highest score. Rather this 4.8. So seal filter clogging is the major cause of the problem. Now you say what I need to do. I mean, let's see what actions. And again, this is based on your maintenance history, your knowledge base, your documents, and then it will say inspect, replace filter, or increase seal supply pressure. So either you replace the filter, but you don't want to replace, then you increase seal supply pressure and still operate your compressor for longer time, right? And you don't need to take any shutdown or repair at this moment, right? Because it's critical for you to produce. So then you can do what if analysis, but I just, because we have limited time, I want to go to other use cases also. Okay. Then after predictive, sorry, I'll go to process performance prediction. In the operation side also, we see some upset and how I can predict early. It can be in steam drum, it can be in rolling mill, and it can be in power supply, upset, how I can predict those issues. So fundamental of this is same like predictive maintenance. You have anomaly detection, you have predictive model, you have cause analysis, but I will just tell you this. This is a very interesting use case we had done for Jindal. We have done for Jindal, and we had done for a Canada steel plant. This is cobalt occurrence in rolling mill is a big problem for them. Was a big problem, and they came to us because every cobalt occurrence in the rolling mill takes almost 30 to 35 minutes for plant shutdown. And that production loss and cobalt occurrence happen quite often. Basically, I think 1 or 2 times in a month, like that. So you think you are losing so much production. So they put a use case that can we do it? Can we predict the cobalt occurrence early? And we use our anomaly detection and everything, and we did that. So this is just a screenshot. Sorry, can you mute, please? Request to mute. Okay, thank you. So here you see, this was a actual, from the plant. We took the historical data. This is coming actual, and here we are predicting model. We are here, it can predict that in 10, 12 minutes, I think, your response time or deviation from the normal will be highest. This is deviation, and this is the response time. They were having in the tail breaker, they have this force applied, and if force is taking more time to apply, then cobalt occur. So normally, if it is taking only 0.4 seconds, see the fraction of second, then it's good, it's normal behavior. If it is taking more time than pneumatic device, then the disturbance happen and cobble occur. The steel bar, hot bar goes out of the band. So what we did, based on the deviation in occurring, our ML machine learning model learned it, and we could detect almost 10 minutes before, hey, you will have a cobble. So what you take action. So I think for them, even 2, 3, 5 minutes before was good. So we predicted 10 minutes before. They are avoiding most of the cobble occurrence now and taking the action. Now, this one is predicting power requirement in steel manufacturing. So as you know, you have EF, you have LRF, furnaces, and there is a fluctuating power demand in these. How you can optimize the power consumption when there is a, low requirement, right, or high requirement. So we did this, work with again steel manufacturing company, and basically they could reduce the power consumption here, surplus power from 15 megawatt to 5 megawatt. I'll discuss in detail if required, in discussion. Then this one was for a zinc plant. This is using computer vision for the product check, quality check, and it can work in steel also. Like we had done a POC for the sintering part, production quality. So here we use computer vision cameras, and if there is a uneven surface or there is some defect in the surface, it detects and tell you the quality of the product, so that you don't send the bad quality to your customer, right? And take the corrective action. You don't produce the scrap material, you produce the right material if you take the action at the right time. So then let me go to so we have done here also, in the prediction, some process performance prediction I was talking about, but just we already talked about the global prediction. I'll just go ahead for the next one, optimization. So in the optimization, how it works.
Just let me make a request. I can see you have a feature of AR VR also, so I would like to have your thoughts about that as well. So you can have your content prepared accordingly. I can see on your home screen there was a AR VR feature also.
Yeah. So we have AR VR. Let me just see if I have those slides here. Yeah. So basically, let me just go here in 3D again. So B plant we call 3D. So here we build 3D, right? So one is depending on the client maturity in the digital, we bring either a crawl phase, walk phase, or run phase. We just give the name. It's basically more like a where you are in the journey. You can start from here if you don't have like 3D CAD and all. This one is basically you just scan and you get like a Google Street, but still you can map and you do things in 3D here. This one, when you have a mesh for critical equipment, you can have the advanced version, but for other you don't need walk phase. This one fully with all integration with real-time data, VR, AR. So VR we were talking. Our 3D integrate with VR. So once you have device, let's say HoloLens, or it can work with any device, then you are basically immersed into the plant. And then you feel that you are in the real time, a real plant, and you can do, it's in the demo, so that's why I can't show. Demo means you need to have the device, but you can just take lot of action using that, and you can see what is happening. It's for training purpose, but VR is for training purpose, but you can use for seeing the performance of the plant also, and for maintenance activity and other things as well. So for VR we need a device. Maybe I'm coming to India in November, and maybe I don't know whether Parthada is having a device, but it will be good to see how our 3D looks like when you have a 3D, this device. So that's where VR is coming.
Right.
So
thank you for capturing that. So I could see one alert popped up that 5 minutes is remaining. I hope the meeting will not get auto disconnected after 5 minutes.
No.
All right. Let's
Yeah.
continue, please.
I'll just take only 5 minutes and then we can have question answer. Yeah. So this one is like walk the crawl phase, right? And this one is walk phase where we use for critical equipment. Oh no. This is still walk phase. Then we go to after this we are having this pro phase, which is walk phase, and with critical equipment we have mesh and 3D more advanced, and finally this one is your BR1 or B Plan 360, where we have everything, including model management of change. Model management, anything coming, it will be updated automatically, right? So I will go back. I just wanted to capture this 3D part. So we were here, Jink, optimization. So very quickly in optimization, I'll just share. We have done you can apply optimization. Let's say you are operating your furnace at certain air flow, fuel flow, and other parameters are there. First is you want to have a real-time performance monitoring using 3D or no 3D, and then you can optimize it. Means, hey, I am operating at these parameters. Can you increase my efficiency, optimize efficiency at what parameters I should operate so that my efficiency is high? And that's where this optimization comes. You have this, we need to build this model using your historical data. Basically, it is like replica of the plant, of that furnace or plant. And AI optimizer will change parameters in this and see the output, let's say energy consumption. We need to minimize. And it changes some manipulated variables, and then you get objective function. So it's an iterative process until you get the global minimum energy. It continues or any constraint hit. At that point, you stop, and then you get optimal operating conditions, which you need to implement in your plant, in DCS, SCADA, EVA system, whatever. And you get optimum energy consumption. We did for blast furnace. Like we did for chemical side also, energy monitoring and optimization. It can be for product optimization also. In that case, it will be product maximization, right? Same fundamental. Then decarbonization, I'll just skip. Copilot. So Copilot, generative AI application, pure generative AI. You don't need to do anything. This is like chatbot type. Again, we will take your chatbot is just for your standalone, not with AI, like we had seen with AI, predictive maintenance and all. But this one, you have, let's say, for HSC, for operation maintenance, for safety and capital projects. You have all the document procedures, all these things can be on your fingertips. I'll show you that. Similarly, this analysis assistant is basically for reasoning. We had seen in predictive maintenance, real-time performance monitoring. This one is workflow assistant, like agents. Means like you have for either for development, coding, you don't need to do code. You can use agent, generative AI, or for process side, like role base. Oh, this is reliability agent. So reliability agent will do everything, will tell, hey, what is happening in this equipment, right? Just pure that role base. So here you bring different type of data, and then you build these agents and chatbot or reasoning. So this is architecture. I will not go. I'll just show you one demo and then we'll open for question answer. Sorry. So this is our chatbot we had done for a client. Let's say for HSC, I can ask question and it will give me the answer like this. Let's say I say what permit I need for vehicle entry. I mean, simple entry. This is HSC. And okay. Oh, no. Okay. So like these are the things, you get, and then you can say, I mean, something is bug here. So let's say I can say, yes, I like this. If I don't like it, I can provide my comment here and save it. It goes into the knowledge base then after that. And knowledge base basically here, then you verify. And once you verify, your verified domain expert will say, oh, this is good answer. You don't need to test, but in the beginning, it's good to have a domain expert who can really verify the authenticity of this platform. And once you get all 100%, 95%, your system is good. You can upload all the documents, but you can do the chat here and ask any question and it will give the answer basically. So with that, I will pause here. I know we are 6:31 here in Houston, which is your 8 o'clock? No. Yeah. No. I don't know, 5 o'clock, I think. Yeah, 5 o'clock. So I'll just stop sharing and go back. Thank you very much. Appreciate your time.
Thank you so much. Actually, that 1 hour, flew away like a zippy. That was an interesting, presentation, and as well as showcasing the hands-on use cases. So nothing instills more confidence than seeing the things in, working. Let me invite if any our esteemed participants would like to ask any questions. I would invite them. They can unmute and ask your queries if you have any.
And I can go to particular slide. I'll share my screen again if required. Let me share my screen. I think it will be better. I just wanted to see because I can't see when I'm sharing my screen. Yeah.
No problem. We can share if it is required. Do we have any questions from any audience?
Really, this presentation is very marvelous and it enhances our knowledge in the various domains as presented by the Mr. Chauhan, Mr. Nikhil Chauhan. Definitely, any process have the generally 3 levels: level 1, level 2, level 3. Level 1 is you can consider the IoT sensors. Level 2 is the DCS and PLC, and level 3 is the supervisory computer or modeling. Nowadays, these are the basic elements. Now, I think this is the one level above that, because it's a very good 3D dimension of an actual process is depicted in this digital twin. And actually, I think it's act as a supervisory or advisory platform. Suppose you can do the offline simulation also here, because in the online control loop, you cannot have the direct interference. So like take the case of blast furnace, you can simulate whether these are the input variables and these are the operating parameters. If suppose anything changes, what could be the output result in terms of quality or silicon prediction like this? So already in level 2, level 3, the supplier give the basic patented models like burden calculation and distribution, cohesive zone prediction, silicon prediction model. So based on that, this is another, I think it's a level above from that, so that we can offline simulate also. And it's you are rightly said that the EBA system all are there, and all this HMIs and all that, where you can have the alert, but you need an expert to analyze what could be the problem. Here, it automatically comes from the modeling what could be the problem. I think it's a big quantum jump in the present scenario.
Oh, thank you, sir. Basically, yeah, you are absolutely right. Yeah, I mean, this is the next level, right? Advisory type. You have assistant with you, right? And I call it assistant, not advisory, right? A human being will still be there, right? And this will give as you said, right? I mean, optimization offline you can do before implementing in the plant, right? I mean, EBA and other system and DCS, SCADA, they can show you the trend, but ultimately what is happening, right? And what action I need to take. In optimization is very automatic, but still you need to implement those things. But in prediction, I mean, we did this with this COBOL prediction and other prediction also. It become very difficult for human being to take the right action at the right time. You can do analysis after, but not before.
In SAIL also, we have done the certain digital intervention in various domains, like digital twins. 2 of our plant, ISP and blast furnace of Bhilai steel plant, they have implemented digital twin, but it has a very much vast scope further also, because presently we are doing the cohesive zone prediction. What is the shape of cohesive zone? If shape is perfectly, then the productivity will be higher. So at least we can have the various parameters which can be put into this AI modeling. And others are the critical rotating machines, asset monitoring, predictive and prescriptive also. They definitely have yield a great result in preventing the breakdowns in some of the plant. So in further phase, we are covering the other more and more equipment to this asset monitoring modules. So definitely whatever is shown in your slide is definitely a very good presentation and very elaborative. So definitely we would like to seek your help whenever you come to India, because SAIL is going a big way to digitalize its processes. We have the two part, IT and OT. For IT, for our all business function, HR, and finance will be taken care of S4 HANA, which will be coming soon, I think in the coming 6 months next year. And for the OT part, presently we have also floated a tender for a consultant who will be preparing the complete digital roadmap of SAIL as on status, to be on status. Based on the gap analysis, the various digital initiative will be chalked out, and they will be implemented successfully in these 3 years of journey. So definitely your intervention in the other our integrated steel plant parallelly, we can go for it. So definitely we would like to have more insight into this and
Sure, sir. It will be our pleasure to work with you and work as a part of your extended team. Let me put that way. And we have a local team. Parthoda is there, Mr. Sumanta Basu, and we have Indian team here as well. I'm the only one from US, but I'm coming in November. I would like to come to Ranchi or Bhilai or anywhere or in corporate office in Delhi, and we can discuss in detail, right? And definitely we can start something small and show you the value. And I mean, we have done with different customer, but love to talk to you.
most welcome.
Thank you, Ved Prakash sir. Thank you so much. Do we have any more thoughts from the house?
So you talked about AI optimizer and digital twin. So do you have any digital twin for blast furnace or coke ovens or any steel of process as a product or in the development phase or somewhere implemented?
Yeah, so very good question. What we do when we develop any product like we had done for blast furnace, we implement at the client side in plant environment in their cloud. Then we don't see anything in the development. So yeah, we already deploy there. Like whatever I was showing demo, those are earlier when we took the historical data, only those we have. So now we have pre-trained model, but it still need to be trained for your model, your based on your data, because each furnace working in a different way, the configuration may be different, right? And your historical behavior is like human behavior is different. My behavior is different from others. So that way we will twin it, but we have pre-trained model for the blast furnace. But there may be some auxiliary system coming in, with the furnace itself. We need to add those if you have those. So depending on how much area we need to cover in the blast furnace. If it is standard, then it will be deployed very quickly in 4 to 6 weeks. If it is little more than that and little complicated, then probably 8 to I would say 10 weeks or so, or 12 weeks now.
Not only for blast furnace, for other steel processes as well.
Yes. So other steel processes, yeah, I mean, we have optimization also. We have prediction as well. And now, depending on the scope, once we identify, like as we were talking about, your consultant is developing a roadmap. And if they have identified the use cases, right, then we can say, okay, for this use case, we already have. For this case, we need to develop. And develop means, again, taking your historical data, develop. Model development is a science, but it's an art also. We can develop very quickly. And main thing is we bring the accuracy by identifying the right algorithm and using our pre-trained model. So we can go based on that journey or roadmap you have. Somewhere we will already have ready-made, somewhere we need to develop.
Also for the Gen AI model, what you are talking about, is it possible to connect to our models? Do you have the necessary background libraries and the models to connect to our, let's say, developed models?
Absolutely. That's generative AI is becoming our, I would say, this client is Indorama. Probably Indorama is a large company, and then we are working with other company Aramco in Middle East. So, they also have same. They have existing, how we can connect generative AI models, our large language models, with their existing system. So we can do that. That's the easy thing. That deployment is like 4 to 6 weeks, or even less than that, depending on the how many documents, how many procedures, how many, whether thousand, millions. So easy to train. We have done it. The accuracy is coming good. So, and in generative AI, like many times the noise come. You want to reduce hallucination and other things. So we have optimized. And we have optimized the operating costs also of the client, for the client, basically, So that's also, I'd love to talk to you, on that part as well, how we can integrate with your own model, with your own system.
Sure. We can have a discussion when you come to India in November.
Sure. So I'm coming in November and Parthoda will be in contact with you, and let's schedule something, and either towards the end of the November or early December. I can stay longer there, and that way we can have a more detailed discussion.
Sure.
Nikhil, by the way, I will be in Rourkela on 16th, 17th for my Diamond Jubilee in my school.
Oh.
So from there, I'll be going to Ranchi. So that will be on 19th, 20th. If it coincides, it will be brilliant.
Okay, we'll be here. No problem.
Sure, welcome.
So you are part of SAIL family, sir. All the time we can welcome you, not an issue, sir. I have one small query that I wanted you. One of the very fascinating feature was your data correlation that your platform was showcasing. As you can understand and make out from the points from our ED digital transformation, sir, that SAIL is currently going through that journey of making that transformation using technologies. But the data correlation that you showcased would require definitely some historical data of the equipments or machines. So what would be the time frame that you can suggest that much of process data must be retained in order to utilize or fed into the different models to get the appropriate correlations? What would be your, because currently all the data which are process data which are getting generated are getting stored as per the local limitations, whatever is the local limitation sizes available in the drives, and then it gets wiped out with the time. So we wanted, just for the sake of sensitivity, that how much duration of data for a critical equipment must be retained on any day if we want to get a any good model giving you a very good data correlations with a very high confidence level.
Excellent question. I mean, this is very, very good. So basically, we need historical data for the training purpose. That data, we need, let's say, or any model required maybe 18 months or so. If you have that data, that's good enough, right? It should have some failure mode. It's good to have. If not, model will auto learn in future, right? So that's for the training and testing purpose. Once you deploy, now you want some hot data which is coming real time to that model and giving you output, but you still need some cold data. Cold data means you want to store in your data lake, data warehouse, right? So you don't want to store 18 months or 3 years data. It's a cost to you. You keep somewhere else. You don't need. You need to see the trend, right? See, your work order management, work order maintenance history is residing somewhere, right, in your APM system and all. But the real-time data is mass, is huge, right? Coming, you saw like rolling mill coming a fraction of second. You don't want to store so much. So I think 6 months data, if it is coming at a minute frequency, that's good enough. Because you want to see, I go back, I want to see how my plant is running in the last 1 week, 2 weeks, and 6 months. If you are going beyond that, then you are basically learning and you are not doing some what you need to do, right? So I think 6 months data at a minute frequency. If you have frequency seconds or fraction of minute, then you need even less. So that's what I say, cold data. For regulatory purpose, somewhere in some countries or some companies, depending on the industry, for regulation purpose, you can keep elsewhere, not in the warehouse, basically. I would say that.
Right. So that brings me to the next queries that I have is the data that we are retaining is what kind of data has to be retained at a on-prem server, and what kind of data can be taken onto the cloud, because when we take off all our process data onto the cloud, then we are facing a challenge of maybe latency, because we cannot run the entire manufacturing unit from cloud. So I would request if if you can shed some light on that. What should be our strategy in data management, in balancing the on-prem data and taking certain section of data on the cloud?
Basically,
So,
sir, question is that what the strategy we should adopt? Either we should in hybrid mode, some critical function on-prem or some other data which are MIS and other on cloud, or whether to go all in cloud, all AI ML in cloud. So what you suggest for this in the steel industry?
yeah, so I mean, what we are seeing, either steel or power or even oil and gas. Yeah, I mean, in earlier, like 2-3 years back, even company like Aramco and Canadian Steel Company, and in US also, Jindal and all, they have plant here. They were very much on the on-prem, because we want cloud security. Now, over the years, and in the last 2-3 years also, asset data was secure even in the cloud, and now it's become more secure. If you are using Azure, AWS, Google Cloud, they are very secure as such. So I would say if there is no internal thing, cloud is safe. Now, on-prem versus this, that optimization part, the cost optimization, I would say. I think security-wise, there is no issue. But at cost-wise, we need to see, how much looking your servers on the on-prem and cloud cost in country. I think that way we can optimize how much we should keep on-prem, how much. And definitely on-prem, psychologically, yes, more safe, right? So if we see that there is really very, very sensitive data, let's put that definitely on-prem and rest on the in the cloud. But having said that, cloud, hybrid cloud is very secure now. It's your own, it will be your private cloud, basically. Not like, that's why I said, remember, like blast furnace, what we deploy at this Canadian client is just there. We can't see it. So same, nobody will see your data, it is your data, it is your model, and that's it.
But one
So,
eventuality had happened to the Tata Nagar Kalinga Steel. They have gone for the complete digitalization, and they hired the cloud. Their total critical function and all being done in the cloud. So I think 5 or 6 years back, there were heavy storms and others in the Orissa port there at Kalinga Nagar. So the connectivity for about 2-3 days got disturbed. So whole plant come to a stop. Later on, they have they have shifted some of their critical functions to the on-prem and then the cloud. So they took this strategy after that happening.
Yeah, that's a great point. I think, that way we can see the sensitivity of the system, that we want those to be running all the time, and these are sensitive from the security perspective, as well as from the reliability perspective, right? So yeah. I think case to case, I would say that's where, even generative AI we were talking, and infrastructure, we need to look the optimization part. One is like this optimization of AI, but running of the course, like generative AI, you can have Azure AI, he will charge 0.6 cent per 6 cents per token. But now there is open source large language models. You don't need to pay anything, right? No, zero. So we have optimized the course now very well. And only thing, we use those open source large language models for training purpose. We are using Azure OpenAI and Mistral and Gemini. But when we deploy to the client, we are just taking open source, so that client cost is low, but accuracy is still high, because we train based on OpenAI also.
All right. Thank you. Thank you so much. It's such an interesting topic. Technology is always something that, intrigues our mind. So
Yeah.
I was just, going through a book called Future Shock, and that book has predicted that in 1980s itself, that technology is going to make the change very faster in our life. And in last couple of decades, story has been same for all organizations. So even manufacturing, and now that steel is also not behind in that domain. So thank you so much, sir. I can, it's very hard to wrap up the session, but 1 hour is the time that we have promised to all participants, and I would like to respect that. Maybe we can, catch hold of you once again sometime. Let me take this opportunity to invite Sri Sanjay Dhar, sir, who is Chief General Manager HR L&D with charge of EDHR L&D, to kindly take forward the session. Sir, please. Sir, you are mute.
I'm audible now. I am. Yes. Thank you, Chandra. And I think we have had a very fruitful discussion. We have discussed about a lot of practical use cases. The session has been very useful for us in terms of really, helping us connect the dots in terms of different technology that we are already using, and connecting different use cases of where technologies can be deployed. And figuring out how do we take a holistic perspective. And I'd like to thank Chauhan Saab for, very diligently and very systematically walking us through the process and making it sound very routine. Okay, this is what you do, this is what you do, and that's it. But the art is in understanding the complexity behind what you are explaining so simply. I'd like to thank Partha Saab also for getting us connected and setting the context for this conversation. AD Digital Transformation is also here. He's also working on a lot of projects and actually working out on how do we connect the big picture. And I'm sure that that's why there were a lot of queries from him. I'm sure he will carry this conversation forward also. I'd like to thank everybody who's participated, because let's appreciate one thing. We are in the midst of a technological revolution where we are actually starting to make sense of it in phases. We understand a little bit of it, then it gets muddled up again. Then we understand a little bit more, then it gets muddled up again. But through this process of clarity and muddling up, we are getting a better understanding of how it works. And thank you very much for helping us, make progress in this journey. So many things more to be learned, and we will continue this conversation. And thank you once again for engaging with us in this process of innovation, because we are also trying to get our people connected through our digital outreach programs for the same purpose, that stay alive, stay connected. There will be confusion, but we'll clarify them as we go along. But don't stay ignorant. That you can't turn a blind eye to the march of technology. So thank you once again, and we look forward to having some more sessions.
Thank you, sir. Thank you. Appreciate it.
Thank you, Partha Saab, Nikhil Saab, Bedprakash Saab.
Thank you.
All the participants.
Thank you. Thank
Again,
you. Appreciate
thank you
it.
very much.
Have a great weekend.
Yes. Once again, thank you very much. All
Thank you.
Wish you all very happy pujas. I think.
Happy Puja.
But don't forget, we will be having our next Knowledge Byte session on the next Saturday, first Saturday of the next month. And towards the end, I would like to thank Atanu Mukherjee, sir, who is Head of Academics, for his unwavering support for making this special Knowledge Byte session a success. Thank you so much.
Thank you.
Thank you.